Hi, my name is Monica. Today I am going to show you how a current carrying wire experiences a force when it is placed in a magnetic field. This force is due to the interaction between the magnetic field produced by this current carrying wire and the external magnetic field. The direction of the force follows Fleming's left-hand rule. The rule says that the thumb points in the direction of the force, the first finger points in the direction of the magnetic field, the second finger points in the direction of the current. And if all these three fingers are placed perpendicular to one another, then the direction of the force can be obtained if we know the direction of the magnetic field and the direction of this current. The magnitude of the force is largest when the direction of the current carrying conductor is perpendicular to the magnetic field. Now I'm going to demonstrate that a force is produced when a current carrying conductor is placed in a magnetic field. Now what you need for this demonstration are the following. I have used two 1.5 volt dry cells. They are placed positive on the left side, negative on the right side. Now you are connected from this positive side to these two parallel pieces of bare copper wires. I'm not sure whether you can see it. So these are the two pieces of parallel copper wires that are sticking out from the edge of my table. Now the other side then is connected back to the negative side. So positive side, negative side. Now I have two additional things here. This is another short piece of bare copper wire which later I'm going to put across here so that the current can flow from here in an anti-clockwise direction back here to the negative side, from positive across here to the negative side, meaning that the current will be flowing from left to right with respect to me. Now, and another piece of material that we need for this particular demonstration is a magnet, a permanent magnet. I have used one piece of permanent magnet. We will look for the North Pole. This is indicated by an indentation on this side. So this side is north, this side is south. Now I would like you to concentrate on this pair of parallel wires. These are bare copper wires. The current will be flowing from my left here across this piece of bare copper wires, a short piece of copper wire, from left to right with reference to me, all the way back again. Now you will notice that when I put this small piece of wire here, and the magnetic field is going from top to bottom. You can see that this indentation shows that this is the North Pole. So when I put it in front down here, you notice that this piece of wire is being deflected away from me. So let's try again. You can see that this piece of wire is deflected away from me, meaning that there's a force that causes this deflection. Now you can see that I have changed the direction of the current. The crocodile clips are swapped. This piece of short piece of bare copper wire is placed across this pair of copper wires, and then you can see that the wire, this piece of wire, moves towards me. So which means that there is a force that is pushing this piece of wire towards me. Now, when the current was going from left to right, the magnetic field was going from top to bottom. We noticed that the wire was deflected away from us. We will see whether this is consistent with Fleming's left-hand rule. First of all, we will use our left hand, place all our three fingers, the thumb, first finger and second finger, perpendicular to one another. The magnetic field is going from top to bottom. the current is going from left to right. And you can see that the thumb is pointing away from us. So this is consistent with what we saw in the first set of the experiment. However, when we change the direction of the current so that the current goes from right to left, we notice that the piece of wire is deflected towards us, which means that the force is pointed towards us. Now, using Fleming's left-hand rule again, we will see that the current is going from left to right. Magnetic field is going from top to bottom. So I'm swiveling my wrist. So current is going from left to right. Magnetic field is going from top to bottom. And you can see that the force is pointed towards us. So this is again consistent with Fleming's left-hand rule. In conclusion, we see that a current carrying wire produces a magnetic field. A magnetic field can deflect a current carrying wire. Discovering this complementary links between electricity and magnetism created such excitement in the early part of the 19th century. Almost immediately, people began harnessing the electromagnetic force for useful purposes. Example, creating meters with great sensitivity and creating electric motors with great force.